Hey guys, welcome to CPM 3. We are on Module 2, Lesson 1. So welcome to Module 2. So we have already learned two ways to graph a line. We're going to learn a third way. But before we can learn that third way, we kind of need to go over what slope is and what it means first. So objective 1 is to find the slope of a given line, or of a line given 2 points of the line. So your first definition here is the measure of steepness or tilt of a line. This is called your slope. Now with slope we have multiple formulas. The one that we need to memorize, that's going to be a little bit harder, is going to be your y2 minus y1 over x2 minus x1. Now, what this does when you find this is simply the change of y over the change of x. Okay, now this right here, you don't need to really memorize, but I do want you guys to see that in case you guys go to functions and modeling or calculus or whatever the case may be. This little triangle is delta, and that means the change in. But when you have the change of your y right here, right, change or right here, this is considered your rise. And then you have the change of your x, which is your run. Now, for our formula purposes, we need this formula and we need this formula. Okay, so don't really worry about this middle one, but I just wanted you guys to see that for when you go on to your next math class. But this y2 minus y1 over x2 minus x1, you use this when you are given two ordered pairs. And then you'll use this rise over run when you are graphing or given a graph. So that's the point of those two different formulas. So, example 1, find the slope that passes through your given points. So, since I have two ordered pairs, I am using this formula here. So, I'm a visual person, so I like to label my ordered pairs. You've got x1, y1, x2, y2. Now, I'm going to show you how this doesn't make a difference. But you just need to make sure that your first coordinate is always x, your second coordinate is always y. That's the way your ordered pair is, right? It's x comma y. And because we have two ordered pairs, that's why you have those little bitty ones and twos. So you want your ones togethers and your twos togethers. You can call this first one your x2, y2 if you want, as long as this one are both ones. Doesn't matter the order you put them in, as long as your x's, your ones are together and your twos are together. So, now that we have these labeled, now this is just straight substitution. So I have y2, well my y2 is negative 2, minus my y1 is 4, and this is over my x2, which is negative 1, minus my x1, which is 2. So now just simplify. So on the top, negative 2 minus 4 gives me negative 6. On the bottom, negative 1 minus 2 is negative 3. And then this one simplifies. Negative 6 divided by negative 3 is a positive 2. So this is my slope. Now this little helpful hint goes with part A. It says the slope is the same if we let x1, y1 be your other ordered pair. So they labeled this one opposite wise. So instead of it being negative 2 minus 4, they got 4 minus a negative 2, so that's opposite. Instead of negative 1 minus 2, they get 3 minus a negative 1. When they simplify, they get 6 over 3 still gives you 2. So it does not matter how you label it, as long as your 1's are together and your 2's are together. Let's try another example. We've got x1, y1, x2, y2. So plug it into your formula again. y2 is 1 minus my y1, which is -1. So be careful here. Your formula has a minus, so that is what this minus right here represents. So now it is minus your y1, where your y1 is a -1. So you kind of have a double negative here. Well, minus a negative or two negatives makes a positive. So instead of writing that as 1 minus -1, we're going to do that as just 1 plus 1. Okay, same thing that's going to happen to the bottom here. You've got x2, my x2 is 3, minus, because that's this formula here, then my x1 is -3. So that means you've got a double negative there again. Well, minus a negative again becomes a positive. So I'm just going to make that a +3. So watch out for those negatives when it has to do with these back ones, because those are going to turn into positives. So now simplify. 1 plus 1 is 2. 3 plus 3 is 6. You can reduce this. You can divide these both by 2. So I'm going to get 2 divided by 2 is 1, 6 divided by 2 is 3, so my slope in this one is 1/3. We're going to get quite a few fractions today, and that's okay. Fractions and slope are not scary. Okay, and then last one here on C, we're going to practice that minus and negative again. Label your points. You've got x1, y1, x2, y2. So plug that into your formula. We've got y2, which is -3, minus, that's my formula, minus a y1, which is 5. x2 is my 2 right here. Then it is minus, so we bring that down. And then my y1, or my x1 is a -1, so you've got that double negative, but minus a -1 is the same as just adding 1. So simplify. -3 minus 5 is -8. 2 plus 1 is 3. We can't simplify that, so that is our answer. Now, we'll get more into this as we keep going, but notice I have -8 over a +3. This is the same as a +8 over a -3, which is also the same as having that negative neutral and then 8 over 3. Okay, so it doesn't matter where this negative goes, it just needs to go somewhere, and it needs to go somewhere only once. So either in the top, the bottom, or right here, neutral. So just kind of keep that in mind as we keep going through this lesson. Now we need to find the slope of each line. So now that A, B, and C here in example 2 are all graphs, now I'm going to use this formula here, my rise over my run. So from the lowest point, how many are we rising, how many are we running? So I am going to zoom in on these. Okay, so on A, my slope is, ooh, that's thick. My slope is rise over run. So from the lowest point, how many are we rising, and then we'll calculate how many are we running. So my rise here is 1, 2, 3, 4. So remember, this is not 1 right here. You haven't moved anywhere. So 1, 2, 3, and then 4 is my rise. And because it is going up, that is a positive 4. Then my run here, and I'll go ahead and put my rise as 4. So then my run, again, this isn't 1 because we haven't gone anywhere. 1, 2, 3. But because this is going to the left, you're going to towards all these negative numbers. This is a negative 3. So my run is negative 3. Can't reduce that, so this is my answer. So remember, it doesn't matter where that negative goes, right? So more times than not, we're going to go from the bottom one to the top one, but you can also start here and travel the other way. You get the same answer. If we use it this way, my rise over my run, the reason I kind of don't like doing it this way is because your formula specifically says rise and now you're going down, but it's the same concept, right? This is my rise, or technically my sink. So from this point here, we're going 1, 2, 3, 4. But now because I'm going down, that's a negative 4. Over my run is now down here. So we're going over, this isn't 1, you haven't gone anywhere yet. This is 1, 2, 3. And because you're going to the right towards all of these positive numbers, it's a positive 3. So either way you go, you get the same slope. It's just, is it going to be negative in the bottom or negative in the top? But it doesn't matter where that negative goes. These are the exact same answer. Okay, so it doesn't matter what direction you go in. On B, we're going from this point. We need to count our rise to our run. So slope is rise over run. So how many are we rising? So from this point, we're going up 1, 2, 3, 4, 5. And because we're going up 5, that's a positive 5. And then my run, this isn't 1. We're going over 1, 2. So my run is 2, and because we are going to the right towards all these positive numbers, that is a 2. Can I reduce 5 over 2? No, we cannot. This is the last time I'm going to do it both ways, but this even works when you get positive numbers. If I was to do my rise over my run, going from the top to the bottom, going from here to here, now my rise is, my sink. So we're going down 1, 2, 3, 4, 5. And because we're going down, that is a negative 5. And then my run from here, we're going over 1, 2. And because we are going towards the left, towards all of these negative numbers, this is a negative 2. So now I have negative 5 over negative 2. Well, I still can't simplify 5 and 2, but I do know that negative over negative is positive. So this becomes 5 over 2. Okay, so it does not matter, again, which direction you're traveling in. And then lastly on C, we're only going to do this one direction. So my slope is rise over run. So from this point, we need to rise and then run over here. So my rise is 1, 2, 3, 4, 5, 6, 7. And going up is a positive 7. And then my run, this isn't 1. This is 1, 2, 3, 4. And because this is going negative towards all of these negative numbers, or going, sorry, to the left towards all of these negative numbers, that means this is a -4. So again, can I simplify 7 over -4? No, we cannot, so that is my slope. Okay, so that's how you find your slope on a graph. Objective 2, we need to find the slope of a given line when we're giving an equation. Okay. So it says right here, we have something called slope-intercept form. And your slope-intercept form is when a linear equation in two variables is written in this form here. Y equals mx plus b. Now, this is going to be the third way we're going to graph lines, is through this form here. But what we're focusing on today is just the slope of this. Your slope is whatever m is, and m is whatever in front of the x. Important thing with this though, you must solve this for y. When you solve it for y, that's when you put it in this y equals mx plus b form. So this form here means you have solved for y. Okay, once we solve for y, we're looking what's in front of that x, and that is my slope. For some reason, m is what you use for slope. So in example 1, is this in this form here? Has it been solved for y? Well, yes, it has. You have y equals y is by itself. So then your slope is whatever's in front of this x. So in this case, my slope is simply 5. Now, this is perfectly fine for your answer. Like I said, we're about to start graphing, right? And so when we start graphing, we've got to start thinking of our rise over run. So I do want you kind of get in the habit of making these into fractions. You need a fraction to graph. So yes, the slope is 5. How do you make that into a fraction? That would be 5 over 1. So let's just kind of write that so we have that in our mind. Okay, so that means when we're graphing, we are rising 5 and running 1. B, same thing. Is this in your slope-intercept form? Has it been solved for y? Yes, it has. You have y equals y is all by itself. So then your slope is whatever's in front of this x. So in this one, it is -2. So again, this is a perfect answer for what is the slope. It is -2. But let's start wrapping our brains around making fractions. So I know my rise, I know my run. So that means make this into a fraction by putting it over 1. So we got -2 over 1. Okay, now B is the first one now that's not really in the correct form. So it's not in the correct form because why? It is not solved for y. It's got to be solved for y, and y is over here, and I've got other junk with my y. So get y by itself. So how do you get y by itself? Well, we got to move this 2x to the other side of the equation, and we do that by doing the opposite operation. So the opposite of a positive 2x is a -2x. My 2x's cancel. I'm left with y equals. Now don't write this. In last module when we worked on formulas, we realized we could not simplify that. Those aren't like terms, so that it doesn't become 5x. One has an x and one doesn't. So last module, we just kind of put them side by side and put 7 minus 2x. Now, this is technically correct, but because I want to put it into this form here, I want my x variable first and then my constant second. So instead of writing it like this, we need to put the x first and then our constant. So this is actually going to become y equals, you've got a -2, so keep that negative with it, -2x, and then your 7 is positive, so plus 7. These are exactly the same thing, but this is in slope-intercept form since it's mx plus b and you have your x term first. Okay, so now that this is solved for y, what is my slope? My slope is right here at -2. And so we get m equals -2 again. And again, to make that into a fraction, that is -2/1. Okay, D, is this in the correct form? Nope, it is not solved for y because we have this on the other side. So to get y by itself, now the opposite of subtracting 5, or a -5x, is to add that over. So that cancels. Now I have y equals, these are not like terms, so we cannot combine. Now let's put that x first. So we're going to go 5x plus 10. This is positive, so keep them both positive down here. So now that I have this solved for y, what is my slope? What's right here in the front? So my slope is 5, and as a fraction, that is 5/1. Okay, now on C, we need to do a couple steps on this one. We need to get this y by itself. So let's move this term to the other side here. So the opposite of a positive 2x is a -1. So we're going to subtract that over. So I get -3y equals, I can't combine those are not like terms. So we're going to put them side by side, but we want that x term first. So we're subtracting 2x. So minus 2x, 10 is positive, so plus 10. Well, we're still not done here. Now I need to get y by itself. So this is -3 times y. The opposite is to divide it over. So that cancels, and I'm left with y equals. When you divide one side by -3, when I'm dividing the left side by -3, remember, we are not dividing one thing or the other by -3. Everything gets divided by -3. So my suggestion, instead of putting this all over -3, because you'll get confused and you'll make a mistake of only dividing one thing, what my suggestion is to put everything individually over -3. Okay, so we get y equals, reduce if you can, -2 over -3. Well, I can't reduce 2 and 3, but negative over negative is positive, so I get 2/3 x. And I can't reduce this, but I do know that positive divided by negative is negative, so we get minus 10/3. Now, it's okay to get fractions here. It's not as nice to get fractions here, but luckily we're not graphing or anything, so I know my slope. And that was the whole goal. So since I've got y by itself, whatever's in front of the x is my slope. So in this one, we get my m equals 2/3. It's already a fraction, so I don't need to do anything else to it. Okay, E is the same thing. So on E, we need to get this y by itself. Solve it for y. So, opposite of a positive 3x is to subtract it over. So I'm left with a -5y, don't forget that minus in the front, minus 5y equals, I can't combine these, they're not like terms, so put them side by side, but we want the x first. So I get negative 3x, since negative 3x here. 1 is positive, so plus 1. Y is still not by itself, so the opposite of negative 5 times y is to divide negative 5. So those cancel. Don't put this all over negative 5. My suggestion is to do these individually over negative 5. So I get y equals, same thing here. Negative over negative is positive, but I can't reduce 3 and 5, so we get 3 over 5x. And then 1 over 5, I can't reduce that, but I do know positive over negative is negative. So minus 1/5. So your slope is what's ever in front of the x. So I get a slope of 3 over 5. It's already a fraction, so I don't need to do anything else with this. One thing I do want to kind of make notice on all of these, I never put the x with it, right? I did not write negative 2x. I did not write negative 2x. That's a bad example since it's the same thing. I did not write 2 over 3x. The x is not included when you're listing that slope. It's just the coefficient. Okay, find the slope of horizontal and vertical lines. So, when you have a positive slope, it's going to go down to up as if you're reading from left to right, right? You always read from left to right. So from left to right, this graph is going in an upward direction. So then your negative slope, as you know, same as you read and write from left to right,